Welcome to the next video tutorial for Open Commissioning. In this video, we will show you how all the tools of Open Commissioning work together by generating a TwinCAT solution containing the behavior models of devices in the simulation. So the basic principle is that the complete model consists of two parts. One part here is running in Unity for the physics simulation and the mechanical simulation, and the other part is simulating the industrial behavior of the devices, which is running in TwinCAT. So we will use the Open Commissioning Assistant application to automatically generate the behavior models of the devices inside the simulation, which then are connected to control parts of the simulation using TwinCAT. So to do that, we need a few things. First, we have to have Unity installed with the Open Commissioning package. How to do that, we showed in a previous tutorial. You can check that out. The second tool we need is the Open Commissioning Assistant application. You can easily get that by going to the GitHub repository of the assistant, navigating to the releases, and download the application from the release page. So I already did that. We can open it, and we see the assistant is running. The third thing we need is to install the Open Commissioning TwinCAT library to TwinCAT. So we head over to the repository, also navigate to the releases, where we can download the library from the release page. To install it, we open TwinCAT, go to PLC, library repository, click install, and select the library, which will take a few seconds to install the library. Okay, so we can close TwinCAT and continue with generating the solution. So first we have to create a new TwinCAT solution. We use the assistant application for that. Under File, Create Solution, and specify the location, specify a name. And now the assistant application will create a new solution based on a template that already has the required settings and a PLC project configured. So we see the solution was created, it was opened in TwinCAT, and the assistant already connected to it. That means that the assistant is now able to generate things within that solution. So if you look into the PLC program, we see the project Open Commissioning, and in here it will create code for every device inside the simulation when we start the automatic generation. So let's start to generate the behavior models for the devices in the simulation. For that, we go into the Unity editor and go to our project game object. This object has the TC-ADS client component attached to it, which has a button called Update TwinCAT Project. When we click that, it will trigger the automatic generation of the behavior models in TwinCAT. So we see the project tree was sent to the assistant, and the assistant triggered the automatic generation of the code inside TwinCAT. So let's talk about what was generated here. So in Open Commissioning, the idea is that a machine consists of the sum of its devices. They can be structured in a certain way but the smallest building block is one single device. So therefore, the complete machine model consists also of structured single device models. The second idea is that a device model is split into two parts. So to get a better overview for that, let's switch to the documentation of the TwinCAT library of open commissioning in GitHub, where there's a good graphic showing the two parts. So one part models the physical and kinematic behavior of the device and is running in Unity. And the second part, which we call the behavior model, emulates the industrial behavior of the device and provides an interface to a PLC program and is running in TwinCAT. When the simulation is running, both parts can exchange data using an ADS connection. So this is exactly what the assistant is generating. For every device existing in the Unity simulation here, it generates a behavior model, which is basically a function block in the same structure as defined in the Unity project. So for example, let's look at the cylinders, which are very simple devices. So in Unity, it is under Project, Devices, Cylinders, Cylinder 1, 2, and 3. In the TwinCAT simulation, we see the same structure, devices, cylinders. If we click on the function block generated, we see that every cylinder corresponding to this name was generated with a function block, which is the behavior model of that device. We can also look at the drives. Here we have 3 different example devices. And if we look in the TwinCAT simulation, we see that for every device modeled here, there is a behavior model generated, which is called cyclically, corresponding to the name and the behavior model. Okay, so let's see that in action. Let's start the TwinCAT simulation and then the Unity simulation and see how they work together. So let's activate the configuration. It's starting to build the project. And now the TwinCAT system is running. So now we start the Unity simulation by starting play mode. And we get the message that the client is running, it is connected, and it's showing how many input and output bytes it's receiving. We can now log into the running TwinCAT system to see the connection between the behavior models and the Unity components of the devices. So let's begin with a very simple device, the cylinder. Let's focus the first cylinder in the Unity simulation and go to the behavior models of the cylinders in TwinCAT. So let's log into the system and open the first cylinder. So first we see 2 variables, status and control. Those are 2 bytes that form the connection between the behavior model running here and the Unity component. So every cycle, TwinCAT reads or writes those values to the ADS server, to which the Unity simulation also connects to and gets the values from. Those 2 bytes are used to contain specific status and control signals of the devices. So in this case, for the cylinder here, we have 2 control signals, retract and extend, and 2 status signals, retracted and extended. Inside the behavior model of the cylinder, those signals are mapped to specific bits of the status or the control byte. So for this first cylinder, we see here the retracted signal is true, which makes sense because in the Unity simulation, of course, the cylinder is retracted as well. So we can force some control values when we are logged into the TwinCAT system. So let's force the extend signal to true, and we expect that the cylinder is extending, which it does. We see that here in the Unity simulation, the progress is 100%. The value is the maximum value, so the cylinder has extended. We also see that in the status signal extended, which switched to true, and of course the retracted value switched to false. When we force the retract control signal to true and the extend again to false, we will see the cylinder will move down again. It will retract and switch its status variables accordingly. So we see retracted is true and extended is false, as seen in the simulation here as well. We can now move to the other cylinders, for example, the second one, and we see the same. The extended value is true. When we set the control signal retract to true and force that, it will retract. And when we set it to false again, it will extend. This is because it's a single acting positive cylinder, comparable to the third one, which is a single acting negative. When we look inside the behavior model, it is of course retracted. When we extend it, it will extend. The status value will change accordingly, and of course again, if we set that to false, it will retract again and show that in the status value. Another very simple device is the binary sensor. When we look at those in the behavior models and look at them in the Unity simulation, we see again that we have status and control bytes, which are exchanged with the Unity components. And we also have an output of the behavior model called value, which represents whether the sensor detects the part here that is moving in this example. So we can see whenever there's a collision, it will switch to true. Otherwise, of course, it's false. Another very simple device is the button, which can be found in the interactions example and button. So let's go to that. Let's jump into the behavior model of the button. Again, we see a status and a control byte. Those get exchanged with the Unity simulation. When we press the button in the simulation in Unity, we see the status byte becomes 1, and whether the button is pressed or not becomes available through the Boolean output called value. So when the button is not pressed, it's false, of course, and when we press it, it becomes true. So we can use this output inside the PLC program to get the status of that button. So let's have a look at a little bit more complex device, the drives. So for example, when we look at the speed drive, we see that in addition to the status and control bytes, we also have two real variables called control data and status data that also gets exchanged with Unity in every cycle. When we go inside the Unity simulation to the drive speed example, and when we force the target value, for example, to 100 degrees per second, we will see that the component in Unity will rotate its axis with that specific value, and also will return the actual value, which represents, of course, the current speed of the drive. So when we force it to 0, then the drive will stop rotating until it reaches 0. In the sample scene, as well as in the library for TwinCAT, there are way more devices and way more behavior models, but we won't go through them in this video. But generally, they work by the same principle. They all have data that gets exchanged with the Unity component, and that data gets mapped to inputs and outputs of the behavior model, which then make up the interface of that device for a PLC program. This was to show the automatic generation of the project and generally how the Unity simulation is connected to the TwinCAT behavior models. Of course, in a regular virtual commissioning project, you don't force values by hand. You use a PLC program to write those values. But for showing that the behavior models are linked to the components in Unity, this was sufficient. So if you're interested, you can go ahead and install Open Commissioning on your own system and explore the other devices in the sample scene or in the TwinCAT library to get a more hands-on experience how they work together. Thank you for watching.